In the last segment, you were shown how to do conversion problems according to a process. Pick a starting place, pick an ending place, look at your units, use conversions to get from beginning to end, cancel units, and then the very last thing you do is use your calculator. You were also instructed to go on to page 12, complete the problems, and then compare to how I do them. So this was your job, to have completed these and compare. Starting place, ending place, conversion factor is centimeter to meter, meters cancel, centimeters here, centimeters there. We multiply and we get 3.8 times 10 squared, or 3,800 centimeters. Kiloliters to microliter have to go through the liter. So 1 kiloliter, 1,000 liters, 1 liter, 10 to the 6 microliter. And we push some buttons on our calculator and we get 2.15 times 10 to the 10. 3 sig figs here, 3 sig figs here. How many grams are in 8.65 nanograms? Gram, gram. So all we need is a conversion linking gram to nanogram. 1 gram, 10 to the 9th nanograms. The 10 to the 9th is in the denominator. So we get 8.65 times 10 to the minus 9th nanograms. Oh, excuse me, grams. Sorry, got ahead of myself. Okay? Now, when you go to English SI metric or SI metric to English, sometimes you need to be given a conversion factor, or you might look one up. In this instance, I gave you this one. So you have to go, if you're going liter to quart, you have to go liter to milliliter, milliliter to quart, which is what I have set up here. 1,000 milliliters to 1 liter. By the way, let me cancel all these. 946 milliliters to 1 quart. Okay, milliliters cancel. Quart is what we're left with. We're going to push some buttons on our calculator. 867 times 1,000 divided by 946. 916.49. Okay, let's try again. 867 times 1,000 divided by 946, 916.49. So you want to try twice to get the same answer. And then we're going to round to 3 sig figs here, 3 sig figs here. This is a definition, so 3 sig figs here. 916 quarts. Okay? Pounds to kilograms means you need to go look this up. And with that, kilograms will cancel. 9,000 times 2.20, 19,800, and I've got some trailing zeros there. 1 sig fig here, so I need 1 sig fig here. And we're going to call that 20,000, or 2 times 10 to the 4th. Okay? Application, all of these are just basic conversions which you should be able to do. Applications mean you have more information, more things that you have to do. So here our starting places are 1.75 liters and a half a gallon. You have to change to a common unit in order to compare. So a half gallon is 0.5 to 1 digit. Okay, and we want to go to liter. So 1 gallon, 4 quarts, and we're going to use this one up here. 1 quart, 0.9464 liters. Gallons cancel, quarts cancel. Liters is what we have here, so we're going to push some buttons on our calculator. 0.5 times 4 times 0.9464. 1.892, 0.5, let's try that again, times 4 times 0.9464, 1.892. And for the purposes of this comparison, we're going to go ahead and keep 3 significant figures because otherwise it doesn't make sense to compare to this. Okay, so our half-gallon punch bowl is 1.89 liters, and we're going to compare to 1.75 liters. So the answer then is yes, our bowl will be big enough because 1.89 liters is bigger than 1.75 liters. And even if we round it to one significant figures, 2 liters is still bigger than 1.75. Okay? Next page. Tailgating party. Okay, so we have 10 kilograms. We have a party of 10, 8 ounces or less. So your strategy here is to get your common units. Okay, so 8 ounces we're going to put into pounds, half a pound per person, 0.5 pounds per person, times 10 persons or people, means we need 5 pounds of beef. Okay, so we're going to compare 10.0 kilograms, let's put that in pounds, 2.20 pounds per kilogram. Kilogram cancels, means we have 22.0 pounds of beef. So, no, 10.0 kilograms is too much. Buy a lot. Either buy less or invite more people to your party. Practice these. Practice, 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 practice. Remember, 10 repetitions per topic for competence, even more for mastery. There should be plenty of problems in your book, more problems in your in-class experience, more problems on the warm-ups. And with that, I will close out this segment and wrap up the rest of our experimental quantities starting in the next segment.